All right, so this is day 2 of verifying trig identities, and today our focus is turning two terms into one, or turning addition and subtraction into a multiplication or a division or just a single term. And your essential question, we've already practiced these skills, now you're working on refining them and coming up with your own process for going through this question. Thank you. All right, so let's go through the process, and I've tried to give you some tips. Now, of course, if you go at these in different order than the order that I have listed here, that doesn't mean that you're doing it wrong. Okay, some people always go step 2 first. They'll decompose every single time, and that's their process, and there's nothing wrong with that. But sometimes when you decompose first, you'll take a problem that's not very long and stretch it out so that it's really long. So my advice is that before you start just tackling the problem, you look at it. You look at its structure. You look at what's on the left. You look at what's on the right, and you see if you can simplify it. So step 1, we're going to look at the problem. Can we apply any Pythagorean or reciprocal identities, or can we factor something out? Because if we can factor something out, that means we're taking two terms and making them one, which simplifies the problem instead of expands it. Step 2, we'll decompose into sine and cosine. So all of the terms are speaking the same language. Then in step 3, just like yesterday, we're simplifying. And I don't really like the word imagine. I'm going to cross it out, and I want you to just write think. Think. You're adding and subtracting fractions, which means you need common denominators. So jealous denominators are part of today's assignment. Also, as a part of the simplification process, we didn't look at this yesterday because it didn't occur. Factoring is an option. Okay? Then we'll apply any reciprocal quotient Pythagorean identities, not ideas, just like we did yesterday. But now these problems are a little more complex, so we might get stuck in a loop. Do step 3, then do step 4, then go back and do step 3, then go back and do step 4. So sometimes we have to repeat. Okay? All right, so we're going 2 terms to 1. So let's look at the problem. Verify each identity by transforming the left-hand side into the right-hand side, and do not change the right-hand side no matter how badly you want to. Okay, so let's just look at this problem. Here I have a subtraction and a little multiplication there equals a single term, right? And we can combine these two things into one thing if we want to. But before we tackle just decomposing this into sines and cosines, let's look at it. Can I see any Pythagorean identities? Can I factor any of those things? Look at term 1 and term 2. There's a cotangent squared in both of them. So I'm going to pick up my red pen every time I do a substitution. So I'm going to try factoring out cotangent squared x so that I am now changing this subtraction into a multiplication. That's an important thing to do when I'm going from 2 terms to 1. So if I take a cotangent squared out of a cotangent squared, I'm left with 1 minus cosine squared x equals, and the other side is cosine squared x. So I'm keeping track of what I'm doing. Over here, first thing I did was I factored. And I changed subtraction into multiplication. Now, before I move on to decomposition, let's continue with step 1. Do you see any trig identities that could simplify either of these things? Right here? What can I replace 1 minus cosine squared x with? Sine squared x. You got it. So here we have cotangent squared x I'm going to use substitution. And I'm going to replace 1 minus cosine squared x with sine squared x. And that is a Pythagorean ID. Okay, so PID is a good enough explanation for your test. I know what that means. Equals cosine squared x. So both of those came from my first suggestion. Look at the problem, try a factor, try some identities. Look how much simpler this is. And is it definitely now one term? Right? We went from 2 terms to 1. Look at that. Okay, so next, what shall we do? What do you think? Now that we've done everything we can to simplify that, step 2, we're going to decompose. So we're going to use a quotient identity to change cotangent into cosine squared x over sine squared x. So we're decomposing into sine and cosine times sine squared x. And if you don't mind, I'm going to go ahead and put it over 1 so that it's in fraction form. Equals cosine squared x. And now I'm going to pick up my blue pen because I use my blue pen when I'm simplifying or if I want to make something stand out. So are you okay with me cross simplifying here? All right. And so here's what I get. Cosine of squared x equals cosine squared x. So we made the left side equal the right hand side, and we did that through simplification. And there you have it. Now you might, when you do your homework, not see that, and you might decompose it first, and it might take you 5 steps instead of 4, and that's okay. Let's take a look at the next one. So again, I would just challenge you to stop and look at the left-hand side is a subtraction, and then the right-hand side is a multiplication. But to me, when I see something like that, I think something got factored out. Because to me, that looks like the factored form of something, don't you think? So to me, when I look at that, I think I'm probably going to have to factor at some point in my process. And if I can't factor step 1, I have to factor step 3. So let's take a look at what we should try. So that's an indication I need to factor. So I'm going to look at the left side. I have a subtraction of 2 terms. And I'm wondering if any trig identities would make this simpler than it already is. Pretty simple, right? I don't think I can replace, there's no trig identity that can make those 2 terms 1. And so I'm going straight to now. I'll go ahead and decompose tangent into sine and cosine. So we'll do sine x over cosine x with your quotient identity for tangent x minus, if you don't mind, I'm going to write the sine x over 1 equals tangent x times 1 minus cosine x. Okay. So sadly, I still have 2 terms on the left, and it's still subtraction, and I really want to convert it to a multiplication. And so I needed to convert 2 terms to 1, combine like terms. Or subtract fractions, right? If I want to subtract fractions, they have to have common denominators. So I'm going to pick up my blue pen just to make a quick little change right here. So I'm going to go ahead and write on the same step here. It's just going to be a secondary step on this problem, so I don't have to rewrite it. Okay, so you can see it's second, right? Because I wrote it under decompose. Jealous denominators. So this wants cosine x over cosine x, correct? Okay, so in my next step, I'm going to subtract my fractions and turn this from 2 terms into 1 term, right? So here's what I have. Sine x minus, is that sine x cosine x? All over cosine x. Because they have the same denominator, I can write them as 1 fraction. Equals tangent x 1 minus cosine x. Okay. So it was successful in taking these two terms and combining them so they're one, but it's a division. And I'm kind of stuck here thinking, wait. So that's a simplification process, two terms to one term. That's just adding fractions, subtracting fractions. But remember that I have a factoring happening over here, right? And so I'm looking at my numerator thinking, can I simplify this? Can I factor out something that would create 1 minus cosine x? Look at it. Sine of x, right? So I think in my next step, what I'd like to try is factoring. This is still step 3 in my simplification process, factoring something I could do. So I can take sine of x out, and that leaves me with 1 minus cosine x over cosine x. Okay, and that equals tangent x times 1 minus cosine x. Okay, so on the left, I have a multiplication and a division. And on the right, I just have a multiplication. But here's where I'm going to pick up my blue pen. And I'm going to point something out. Look at what I've made happen. I have the quantity 1 minus cosine being multiplied times tangent and being multiplied by sine over cosine. Do you see tangent appear here? Yes. Right? I can replace sine over cosine with tangent. And so that would be a quotient ID that will allow me. And maybe you grab your highlighter out and you highlight sine of x over cosine x. I think that's what I would do. So let me see if I got a highlighter here. Do I have one? I do. So I'm going to highlight that guy right there. Okay? And then I'm going to highlight my QID to indicate that those two things go together. And repeat or replace. So tangent of x times 1 minus cosine x equals tangent of x. And we were successful. So decompose, simplify, simplify, quotient ID. Questions about that? Okay. Let's take a look at the next one. It's somewhat similar to the last one. If we look at it left and right, just look at it. We have a subtraction and a multiplication equals a division or a quotient. So, options. We have 1 over cosecant. Well, what is that really? If I decomposed it, it would be sine, right? So I basically want to make this equal sine, and then I can convert it to 1 over cosecant. So, are there any trig identities that you see right here that could help us simplify these three things into 2 or 1?
Yeah.
Where?
That one, yeah.
This one?
The first one and cosecant.
You gotta decompose them? Okay, so that's step 2, right? So we could only decompose. I can't factor anything out. Or I'm not seeing something that I can factor out. And I don't see a Pythagorean identity because there's no squareds. Okay, so let's go ahead and decompose step 1. Decompose. All right, so we're going to change cosecant to 1 over sine of x minus cotangent, which is cosine x over sine of x. And I don't have to decompose cosine of x, but if you don't mind, I'm going to go ahead and write it over 1. And I am going to put parentheses around that because order of operations say I multiply before I subtract. Truth? Okay. And then how about let's simplify? Do I have jealous denominators here? I really don't think I do. Right? Well, let's rewrite it anyways. So that's 1 over sine x minus Oh, I need my red pen because I'm substituting. Cosine squared x over sine x. True? Oh, that's so nice. Look at that. Those aren't even unlike denominators. And so my goal is to try to get to a division. I still have a subtraction, but they have common denominators, right? So on this, so that was just simplify. That's all we did there. And we don't need common denominators. So let's go 2 to 1. So 2 to 1 says we have 1 minus cosine squared x over sine of x equals 1 over cosecant x. So that's 2 to 1. I forgot my 1. Simplified. So now we have a division equals a division. Look at that. Not bad. What do you suggest we do now? So we've decomposed and we've simplified twice. Let's see if there's any identities we can apply. I see a Pythagorean identity. What can I replace 1 minus cosine squared x with? Sine squared x. So we have sine squared x over sine of x equals 1 over cosecant x. And that is a Pythagorean identity. So that was step 3, or step 4. Let's simplify. So back to step 3, simplify. What's sine squared x over sine x simplified to? Sine x. And hey, doesn't sine x equal 1 over cosecant x? Right, so that step was simplify. And last, what will we apply? What trig identity will we apply? We got reciprocal, quotient, or Pythagorean? Reciprocal. So recip ID, and I don't know, that's just RID. RID, reciprocal ID. Rid. 1 over cosecant x equals 1 over cosecant x. Good job. Got questions? Are you on overload? Are you guys good? You're on overload? You just want me to stop? Well, I'm not going to do that. Okay. All right. So let's take the next one on then. Look at this one. It's a division equals a number. So 2 terms to 1. So the first thing I'm doing is wondering. It's almost decomposed except for the fact that I have cosecant in the numerator of my first term. And I'm wondering if I can push it to the denominator by writing it as 1 over sine. So I'm looking at this, thinking, can I write this division as a multiplication that looks like this? Because everything else is already decomposed. But if I decompose cosecant right here in the numerator, I'm going to create a complex fraction, which is not a problem. I can handle it. But I'm wondering, do we want to rewrite this as a multiplication problem? So cosecant x times 1 over cosine x. So that I've changed this division into a multiplication. Do you see it? Minus cosine x over sine x. I don't want to change that. It's already decomposed. Equals tangent x. So that's just write division as multiplication. That's all I did. Divide to multiply. I separated my quotients. Now can I decompose this and not create a complex fraction? Do you agree? So I can rewrite cosecant as 1 over sine of x, right? Times 1 over cosine x. So that's my first term, minus cosine x over sine x. equals tangent of x. It's an option, changing division to multiplication so that you don't create complex fractions. Now let's simplify. So we did a decompose right there. Now let's simplify. So let's multiply, because multiplication comes before subtraction. 1 over sine x cosine x minus cosine x over sine x equals tangent x. We're still at 2 terms equals 1 term. So how do we go from 2 to 1 when we have fractions? How do I add fractions that don't have like denominators? I make them have like denominators. Joe's denominator, what does its denominator want that I'm going to pick up my blue pen. I'm going to make the change here. So I'm going to do common denominators as step 2 in this process so I don't have to write an additional line. Joe's denominators, this one wants what? Cosine x over cosine x. And now can I write 2 as 1? You guys ready to 2 to 1? Okay, so step 2 to 1, that would be 1 minus cosine squared x over sine x cosine x equals tangent x. And 1 minus cosine squared x keeps happening a lot in your notes. So I think 1 minus sine squared x is going to happen a lot on your homework. Because I would just switch the problem up a little bit so that you would have something to refer to until you come up with your own plans. Do you see? Okay, so we did a little simplifying at the beginning. We decomposed. We simplified and simplified. Now let's use a trig ID. What do you see? Right here, right? So that is a Pythagorean identity, right? So PID gives us sine squared x over sine x. Oh, that should be in black. Over sine x cosine x equals tangent x. I'm going to grab my blue pen to simplify if you're okay. I'm going to cancel one of the sine x's. So there's a simplify. I'm just going to put simplify in that same step as the second part. And then we're going to use quotient ID to convert sine of x over cosine x into tangent x equals tangent x. And let me just reiterate, I know that I say this often. You might do this in a different order than I do. That doesn't mean that your order is wrong. You might discover something that I haven't thought about that might make my life easier. So if you find anything, let me know. Any questions before we move on to the beast on the back? Okay, here we go. So here we have something different. Can you tell me, when you just look at this problem, one thing that's different? Just one thing. You see a coefficient right here? That's kind of different. We don't usually see a coefficient. So 2 secant x. So I've been curious all day if this first thing equals 1 secant x and the second term equals 1 secant x and 1 secant x plus 1 secant x equals 2 secant x, but I haven't had time to investigate my theory, but I'm wondering about it. And I might investigate it after school. What else do you see that's a little bit different? Say that again? They're reciprocals of each other. Do you see that? But we're adding reciprocals. Too bad we're not multiplying reciprocals. What else? Anything? Anybody notice that there's a binomial in the denominator? Yeah, we haven't really attacked that very much. So that's the other thing. Okay, and it's already decomposed as well. Yes? So that's interesting. All right. So let's tackle this problem. It's already decomposed, and I don't see any way to simplify this. I don't see any trig identities that would make this easier to do. So I'm already in step 3, make 2 terms, 1 common denominators. So I'm going to pull up my blue pen to do my common denominators. So each denominator wants what the other one has. So this denominator wants 1 minus sine x, and that's a quantity. So remember to tuck a quantity around it. 1 minus sine x, top and bottom. 1 minus sine x. And in your numerator, make sure you put a quantity around that binomial in your numerator. Okay, so there we have that. How about on this side? What does this denominator want? I'm going to tuck parentheses around it because it's a binomial. It wants cosine x over cosine x. Okay, so now can we write those as one fraction? Now that they have the same denominator. So I'm going to go 2 to 1. But I'm not going to simplify the top. I'm just going to go 2 to 1. So here's what I have. 1 minus sine x times itself plus cosine squared x. I am going to go ahead and put those together because that's math I can do pretty simply in my head. Over cosine x times 1 minus sine x. And that equals 2, and I should do this in my black pen, 2 secant x. Okay, so listen, I'm already thinking, I see a 1 minus sine x in my numerator, a 1 minus sine x in my denominator. And if I could just show this some love, and if both of these terms somehow this has a 1 minus sine x, but does this one have a 1 minus sine x? It does, but it's hard to see. So I'm just going to keep simplifying my numerator, keep simplifying and simplifying and simplifying. So I'm going to multiply this out. So what do I get? You guys tell me. 1 times 1. And then negative sine x and negative sine x is negative, no, I'm adding. Negative 2 sine x, not multiplying. Negative sine x minus sine x is negative 2 sine x. And then negative sine x times negative sine x, positive sine squared x, plus cosine squared x over cosine x, 1 minus sine x, equals 2 secant x. So we simplified our numerator a little bit by doing multiplication. And now I'm thinking I can maybe simplify this a little more. So I'm putting my eyes where I see the squares. My eyes are right here. I can replace this. That's a trig identity. That's a Pythagorean identity. What does sine squared x plus cosine squared x equal? 1. So if you're okay, well, I'll just write it again. Crazy next door. 1 minus 2 sine x plus 1 on, let me do that in red because I'm doing a substitution there, all over black, cosine x, 1 minus sine x. Notice I haven't really touched my denominator. It's factored out. It's pretty simple. I like it. Okay. So that was a Pythagorean ID that I just did right there. Okay, can I continue to simplify my numerator? I'm still in simplification mode here. So that would be 2. 1 plus 1 is 2. Minus 2 sine x over cosine x. 1 minus sine x. I'm going to go back and put my equals 2 secant x equals 2 secant x in there. Okay. So that was just simplifying. That's what I did there. Okay. What do you suggest I do now? Anything? Remember that factoring is an option. I'd really like to get rid of, because cosine and 2 are connected to 2 and secant, aren't they? But I really don't need this 1 minus sine x. So I'm wondering if you can see something I can do in my numerator to separate the 2 from the 1 minus sine x. Do you see it? Factor out the 2. So let's factor it. So we'll factor out the 2, and that leaves us with 2 times 1 minus sine x over. And at this point, you probably feel comfortable to leave me behind and finish the problem on your own. I'm going to grab up my blue pen to do my simplification. And I'm wondering if you see, can I convert right here, right now? Right? So I factor simplify in the same step. And then I can replace 2 over cosine x with 2 secant x because they're reciprocals of each other equals 2 secant x. And in that step, I applied my reciprocal identity. And you have a problem that's very similar to that. And so your assignment, which we have about 10 minutes left of class, is this. On the same worksheet as yesterday, you're doing problem 1, 4, 6, 8 through 12, and 18 through 21. It's 11 problems. Don't spend more than 45 minutes on your homework. Hopefully it only takes you about 30. But if you hit 45 minutes, just stop. I'll give you time in class to work on it on Friday. So, do your best so that you can prepare for tomorrow, because tomorrow's the most challenging. But don't kill yourself doing math homework, okay?